Welcome everyone to the AI Research Roundup. I am your host, Alex, and today we're diving into some really interesting work on making conversational AI, more conversational. This post from Google Research, published June 3rd, 2025, is titled Learning to Clarify, Multi-Turn Conversations with Action-Based Contrastive Self-Training. It introduces a method called Action-Based Contrastive Self-Training, or ACT, designed to help LLMs better handle back-and-forth conversations, especially when it comes to disambiguation. That's the crucial skill of recognizing when something is unclear and asking a clarifying question, rather than just guessing. ACT is a data-efficient tuning approach that uses reinforcement learning, where the model learns from trial and error, and contrastive learning, which involves learning by comparing good and bad examples. It also incorporates on-policy learning, meaning the model learns directly from the actions it currently takes. This approach builds upon techniques like direct preference optimization, or DPO, which is a common method for aligning models with human preferences. The research demonstrates that ACT substantially improves conversation modeling, particularly in data-efficient settings. For instance, it can achieve up to a 19.1% relative improvement over standard supervised fine-tuning, a typical step for teaching models to follow instructions, and can even match or outperform larger frontier LLMs in these low data situations. The authors also introduce ambiguity, a novel task for developing agents that can handle ambiguous requests when generating structured query language, or SQL, code, which is the language used to interact with databases. Alright, so this figure really sets the stage for why the action-based contrastive self-training method is so important. It shows a user asking an ambiguous question. What is the recorded investment for Americas based on a small table? The agent could wrongly assume the user wants lease receivables, or it could engage in overhedging. That's when it provides too much information, like listing all possible investment types, potentially confusing the user. But the ideal response, highlighted in green, is to ask for clarification. What kind of recorded investment are you asking about? This clearly demonstrates the need for better disambiguation skills in conversational AI, which is precisely what the research aims to improve. Okay, so building on that need for better disambiguation, this diagram shows the tuning phase of the action-based contrastive self-training method. It illustrates how the system learns. Starting with a prompt and an initial preference dataset, that's dpref. The policy model, which is the model being trained, generates a response. An action classifier then checks if this response is the right kind of action, like asking a clarifying question. If it's a wrong action, that new response updates the losing example. If it's the right action, a user simulator helps play out the conversation, and depending on whether the final answer is right or wrong, this whole multi-turn interaction updates either the winning or losing example. This on-policy learning and trajectory simulation are key to improving how the model handles these back-and-forth exchanges. Moving to the results. This graph really drives home the effectiveness of action-based contrastive self-training. We're looking at clarification reasoning performance, measured by the drop F1 score. That's a metric evaluating how well the model can reason over text to answer questions, with higher scores being better. The horizontal axis shows the number of conversations used for tuning. The red line, representing action-based contrastive self-training, consistently outperforms the dark blue line for supervised fine-tuning. You can see that even with just 50 conversations, action-based contrastive self-training achieves a 24% improvement in clarification reasoning and a 19% improvement in action optimization over supervised fine-tuning. It also surpasses the performance of Gemini Pro using prompting with the same limited data, showcasing really strong data efficiency. In fact, the graph indicates it can be up to 5 times more data efficient in some cases. Okay, to understand what makes action-based contrastive self-training so effective, this table presents an ablation study. An ablation study, well, it's where researchers take apart their method piece by piece to see how much each component contributes to the overall success. First, under action importance, we see that full action-based contrastive self-training significantly outperforms a version where actions are chosen randomly. For instance, the macro F1 score, which is a broad measure of accuracy, drops from 82.2 for the full method down to 63.2 with random actions. This really underscores that intelligent action selection is crucial, Then, the ablation of ACT subcomponent section digs deeper. Removing on-policy sampling, that's when the model learns directly from the responses it generates during training, causes a noticeable dip in performance across all metrics like turn F1, trajectory F1, and post-clarify F1. The turn F1 evaluates single conversational turns, trajectory F1 looks at the whole conversation, and post-clarify F1 measures success after a clarification. Removing trajectory simulation, which is the ability to play out the conversation to see future consequences, also hurts performance, though not as much as removing on-policy sampling. The full action-based contrastive self-training, with all its parts, clearly performs best. Finally, the table shows action-based contrastive self-training applied to different foundation models, Gemma 2B and Mistral 7B. In both cases, applying this training method leads to better scores compared to just using standard supervised fine-tuning on these models. For example, with Mistral 7B, the trajectory F1 score jumps from 51.4 with supervised fine-tuning to 57.6 with action-based contrastive self-training. This shows the benefits are not limited to just one specific model. Alright, so to bring our discussion on action-based contrastive self-training to a close, it's evident that this technique provides a very effective path for enhancing multi-turn conversational abilities in AI, particularly in low data scenarios. We've seen how its core components, like on policy learning and trajectory simulation, are crucial for achieving those impressive gains in clarification and overall task success, outperforming standard methods. This really pushes forward how we can build more nuanced and helpful conversational agents. That's all for this AI Research Roundup. Thanks for joining me.